Welcome to Lesson 16, Day 2, Transformations of Exponential Functions, where we graph transformations of exponential functions by hand. Well, we'll get there, and probably confirm a lot of things along the way using Desmos or some sort of graphing utility. Let's do the intro task together. Consider the following functions in the table. How do they differ from f of x equals 3 to the x? We're changing the base from 2 to 3, just for a little bit of a different example. And I would encourage you to pause the video. I'm going to answer the questions. I'll probably talk about them anyway. But go ahead and answer what you think the transformations are that happen to g of x and h of x, and let's just come back and compare them. Skip ahead like 30 seconds or so, or a minute. Okay. So pause if you want now. Okay, that was plenty of time if you didn't, without wasting more time. So here it is. You didn't pause, but we're going to watch the video. Let's go. Or maybe you did and you came back to see why. So g of x equals 2 times f of x plus 3. When you have a function and it's being multiplied by a constant value in front of it, that's going to be a stretch in the vertical direction. It's also going to look like a squeeze in. I'm going to put a vertical stretch because a vertical stretch looks like a squeeze in. Last of all, the plus 3 means that we're going to shift the entire function from where it was. It's the order of operation, so it happens last. We're going to shift the entire function up 3 spaces. That's a g of x. For h of x, moving on. For h of x, because we have a negative out front, that negative out front is a flip over the x-axis. So we're definitely flipping over x. X for flips down, x for x-axis. The minus 2, because it's happening on the inside of the parentheses, that's going to modify a shift in the horizontal direction. So minus 2 is the same as shifting to the right 2 spaces. Again, I recommend that you focus on the y-intercept or focus on where the function crosses a specific coordinate point, and then think about how you would move that function like you're adding 2, you're taking away 2 from it, but you want to preserve it. That taking away 2 is like trying to be accommodated by shifting to the right 2 spaces. So like there's no mistakes. Everything still continues to line up. A negative inside the parentheses corresponds to shifting to the right. Okay, let's go on to classwork and notes number 1. Given that f of x equals 3 to the x and g of x, oh hey, we're studying that one from up there, is the transformation of f. Follow the steps to complete the transformation of several points from f to g. So 0, as in 3 to the 0 equals 1. Easy enough. So 3 to the 0 equals 1, and then you're going to take that 1 and you're going to multiply it by 2. 1 times 2 is 2. And then the last part, after we multiply by 2, then we're going to add 3. So 2 plus 3 makes 5. Go to a different color. So plugging in a 1, 3 to the 1 is 3. We're going to double it. So that's it right there. The parent function stretches from 1 to 3, but when we double it, that stretch is now going from 2 to 6. So it was a gap of 2, then we double it. Now it's a gap of 4. So in terms of what this 2 does that's outside the function f of x, we're stretching or we're doubling the gap between spaces by 2 every time. And filling out the table. Okay. A negative 1. 3 to the negative 1. It's a negative exponent. Negative exponents flip the fraction. We're going to multiply by 2 and add 3. 3 plus 2/3, 11 thirds. That's just gross. Oh well. It is what it is. Okay. 3 squared is 9. 9 times 2 is 18. And then add 3. Change color. 3 to the 3rd. Do you know 3 to the 3rd? You should. It's 27. Then we're going to double it. Do you know 27 times 2? You should. It's 54. Then we're going to add 3. Do you know 54 plus 3? You should. It's 57. So the reason for this table is just to show you what happens first, then what happens next, then what happens, then what happens, then what happens. Keep going. The order of operations imply a procedure for considering steps in a transformation. So if we say that we have 3 to the x goes to negative of 3 to the x minus 2. Let's rewrite that. It's negative 3 to the power of x minus 2. The original function was 3 to the x, but we're making it negative, and we're taking the x in the exponent, and we're re-expressing it as x minus 2. We can still follow the order of operations, though. It's just the order of operations are happening, well, they're happening with f of x, but they can happen with this expression as well, because this expression is f of x. So 0. F of x is 1. 3 to the 0 is 1. Then we're going to subtract 2. I don't know if I agree with this. We should be following the order of operations. So I think this is a typo. We should be writing this as x minus 2. Then we should write this as 3 to the x minus 2. And then we should be writing this as negative 3 to the x minus 2. This is out of order, which means that these are out of order. So 0 goes to negative 2. And then 3 to the negative 2 minus 2. So that means 3 to the negative 4. 3 to the negative 4 is 1 over 81. And then the last part is make that answer negative. So we're attributing the negative at the very end. So negative 1 over 81. Okay? So making adjustments here. The 3 and the 1/3 and the 9. 1 minus 2. Okay? 3 to the negative 1 is negative exponent. And now make that negative. Okay. Negative 1 minus 2. And 3 to the negative 3rd is 1 over 27. Again, so I'm trying to show that I do what's in parentheses, then I do what's in function notation, then I do what's outside the function notation, and I follow PEMDAS along the way. So if I use a negative 1, in the parentheses, it's negative 1 minus 2. And then I use this number with the function, so 3 to the negative 3rd, that gives me 1 over 27. And then last of all, because the function is negative f of x minus 2, I have to make that negative 1 over 27. In fact, all of these answers will be negative because the function never touches 0. So if we're going to flip it over the x-axis, we're going to go from every number positive to every number negative. It's totally a change in the range of the function. Okay, 2 minus 2 is 0. And 3 to the 0 is 1. And then make it negative. 4. 4 minus 2 is 1. 3 to the 1 is 3. And then make it negative. And because I realize there's a typo in the table, I'm trying to be consistent with g of x, but there's a typo in the table, let's add a 4. 4 minus 2. 3 to the 2. Make it negative. You know what? That was so fast. I'm going to do one more. 5. 5 minus 2. 3 to the 3rd. Make it negative. I bet you that if I plug in f of x equals 3 to the x, so f of x equals 3 to the x, and then I go negative f of x minus 2, and I look at the table of values. Not that way. There we go. 2 should be at negative 1, and it is. 3 should be at negative 3. 4 should be at negative. Okay, I stand by the adjustments to the table, and mainly the fact that the headings were wrong. The headings were not focused on do what's in parentheses first, then attribute the function, then attribute the negative in front of the function. Function? Let it go. Okay, turn the page. Okay. Graph the functions f of 3x and g equals 2 times f of x plus 3. 3 to the x, I mean, was for f of x. And h of x equals negative f of x minus 2 in the previous section. Use the tables provided to plot a series of points. So I've kind of got those series of points. Or I can just go back and gather. This is positive. 3, 4, 5. 3, 4, 5. Okay, so for f of x, I have 1, 3, 1/3, 9, 27. 1, 3, 1/3, 9, 27, 81, 243. Those are useless numbers, though. I can't really plot them. Okay, g of x, I have 5, 9, 11/3. 5, 9, 11/3, 21, and 57. And then h of x, after we just did our fix, this one's going to be a little more challenging. Negative 1/81st. Negative 1/3. Negative 1/27. Gosh, this is dumb. Negative 1, 3, 9, 27. There we go. Bring it back. Bring it back. Okay. So to plot f of x, I'm going to plot 0, 1. And 1, 3. Negative 1 and 1/3. 2, 9. I can't really plot more than that. So this is 3 to the x. Okay, now I'm going to plot g of x. 2, like doubled, and increased by 3. So 0, 5. And 1, 9. Okay, negative 1. Let's see, 11/3 is 3 2/3. Yeah, 3 2/3. So negative 1 and 3 2/3. And there's our line. And then last of all, this one that's here in black, like the fact that 0 is pretty much right there, and 1 is about right there, 2, 3, these are negative, there we go, 3, 4, and so this function looks something like, come on, there we go, like that. Arrowheads, labels, arrowheads, labels, arrowheads. There we go. That's graphing it by hand. The point of graphing it by hand was from a table. We could create a table of values. You can always create a table of values in order to determine the shape of the function. And creating the table of values might, take some time. So really what the next exercises are about is about doing that work more quickly. So if we know what g of x looks like, and we know from the work we did on the previous page about how the y sub 1 and y sub 3, they just were flipped of each other, or a better picture is here, how we have flips of each other. If we know that this is the case where this one is 1/2 to the x and this one is 2 to the x, all we need is make a fraction of it that it's going to flip it over the y-axis. That gives us the chance to graph g of x, but instead of having it be 2 to the x minus 3, we can just flip it around. Hang on a minute, here we go. So 1/2. 1/2 to the x power looks like this. How do I know? Practice. And no calculator needed. Reference previous work. Label f of x equals 1/2 to the x. So in order to consider g of x, and without using technology to graph it, remember the two things that we're going to do. We're going to double every point. So this gap space right here is a gap of 1, and the next one over is a gap of 2, and the next one over is a gap of 4. We're going to double all of those gaps. But we're also going to shift everything down by 3. So where this approaches 0, now it's going to approach -3. And then, let's see, 1, 2, 3. There's my y-intercept. That has to be right there. Instead of it shifting up by 1, now it's going to shift up by 2. And now, instead of shifting up by 2, now it's going to shift up by 4. And then shifting up by 8. So I have something that looks like this. This is g of x equals 2 times 1/2 to the x minus 3. Let's graph it. Let's see what we get. Get rid of you, get rid of you, get rid of you. Okay, 1/2 to the x. Cool. Now let's go 2 times 1/2 to the x minus 3. And you can see it's red on my graph, but, excuse me, purple and red, they line up. And to reiterate my point, this gap to this gap, we're not changing by a ton, but we're changing by enough. So to the left 1 space, but up 2 spaces. Wait, what'd they do? Two x squared. This is their y-intercept. This is my y-intercept. I'm going to think about that for a little bit, because maybe what I need to do is go and make the table for a minute and just focus on what's actually happening and be able to define that a little bit more clearly. I do agree that if this point right here is, you know, creating that, let's see if I can lock it in. I can't lock it in. I can type it in. -1, 2. Okay, so this point right here to this point, that is a rise of 1, run of 1. And from this point to the one that's directly in line right there, that's at -1, 1. Okay, that point, from this y-intercept to this one, we went and we doubled that gap. What I'm having a problem with right now, just being honest right now, is that we shifted from 0 down to 3. Not every point is shifted from 0 to, like shifted down 3 spaces. For example, this point is only shifted down 1 space. This point is shifted down 2 spaces. What's this point shifted down? So we're at like nearly a half down to there. If we go by 1s. I am perplexed. I don't have a good reason right now, and so that's bothering me. I don't want to get to one. Let's try another one and see if, as I try another problem, I'm not going to continue being stuck on this problem, but we can gain some progress on other ones. Okay, no issues so far. Just looking at it right now. Given that f of x equals 2 to the x, so that's this graph. In order to graph negative, negatives out front. Negative out front means flip it over the y-axis. So this point goes to there. This point goes to there. 1, 2, 3, 4. 1, 2, 3. And so what we end up having happen is these points all get flipped from one side of the graph to the other. Sketch a smooth curve. Try to get close to the x-axis. And then, of course, label it. This is g of x. Okay. That's A. No technology needed. Graph it if you'd like. But when you graph, you'll realize that, or you'll see that purple is the function. Okay, go to B. 2 to the x. So therefore, 2 to the negative x. The negative's inside the parentheses with the x. That's a reflection over the y-axis. So this point is going to move to there. this point stays. This point is going to move to there. And there. And so we wind up having happen is a curve that looks like that. I mean, that looks really, really blocky, but that's the idea. This is going to be g of x arrows. G of x arrows. Okay. I'll do one more. I'll do one more, and then I'll leave like this one will be extra practice. Okay. So given that f of x equals 2 to the x, and that's the given graph, then the 1/2, because the 1/2 is out front, that's going to take every y value and reduce it by, well, yeah, is that the right way to think about it? It is kind of, I guess. Certainly the gaps from one point to the next are going to be cut in half. So like the gap from 0, 1 to 1, 2, that's going to be cut in half. The gap from 1, 2 to 2, 4, that's going to be cut in half. Oh. Every y value, cut it in half. Cut it in half. And so we get this function. I'm going to graph this just so I'm not lying. I feel good about not lying. 2 to the x and 1/2 times 2 to the x. There are times in there. There we go. Yeah. Yeah, for sure. 1, 1, 2, 2. Yeah, okay. Yep. So I agree with that function right there. Okay, please do this one, extra practice. Pause if you want to, and then join me on the next page. All right. Staring at the closing. Explain how you would graph 2 times 2 to the power of x plus 3 plus 1 by hand. We had that one before, didn't we? Was that in the previous closing? What was the previous way that this was said? Yeah. So from 2 to the x, we would have a vertical shift. The first thing we should do is the horizontal shift. Then we should double every value, and then we should, yeah, so everything gets shifted over by 3. And then wherever those are, those y values, we double them. And then from there, we add 1. Maybe that's what it was that was with this problem. Not you. Where'd you go? So it's a problem of not having your stuff hole punched and in a binder. Because after you're done talking about it, what do you do with it? This one. I think I'm going to save this for Friday. I'm going to come in on Friday when I'm back. Hi. And we'll go over this one together. Because I specifically want to address the whole -3 issue. Figure out why that is doing what it's doing. Yeah, that's an important thing for me to do. Okay, on page 27. Am I skipping something again? Focus. Well, I'm just going to tell you that you need to do the exit ticket and you need to do the closing success criteria statements, like can you actually graph by hand. And then do the problem set. Be ready to talk about it or turn it in, or at least show that it's done. This isn't your guys. Okay, well, there will be another video upcoming, and so after you note this one, just be ready to follow the links to go to the next ones. Thanks. Bye.